Hello again. We really hope you enjoyed your break and spent your time productively. I want to introduce our next speaker, Vasudev Maduri. Vasudev is a cloud solutions architect specializing in AI and machine learning deployments and edge computing. His topic is unleashing the power of Gemma from cloud to edge. Let's welcome him.
Can you hear me now? Is it audible? No? Yes? Okay. It works. Does it work? Oh, okay. Is it better now? It works? No? Okay. Oh, okay. Maybe. Yeah. Thanks. Yep. Thanks for joining in today. So today we are going to look at Gemma. So just before we start, so how many of you have tried building AI models at your work or some? Oh, is it? Oh, no worries. Sorry. So how many of you have tried building AI models at work or out of personal interest, maybe, not the consumer mode like ChatGPT or Gemini. It's like building your own models or your own flavors of it. Okay. No worries. So in today's session, we'll have a look at open models. So it's similar to what we use day in and day out, like Gemini and ChatGPT or Perplexity, but from the developer lens. So how exactly we can build a model, and what are the available options, and what are the ways of deployment we can do, whether is it for mobile developers or web developers or like a backend developer or an architect, how exactly we can build the models. So just a back history about open models. So did anyone try open models? Yeah. So which model did you try? Oh, okay. DeepSeek. Okay. Yeah. Any others who have tried a different models? Okay. Yeah. So I think historically, Meta was very prominent in pushing out open models. So this was way back in 23, end of 22, where they have released a few alpha models related to Llama. And that's when there was a periodic shift in releasing the open models compared to the so-called proprietary models and closed models. So Llama started in 23, and then DeepSeek and Quen, and these are the most popular ones which we generally use. And the most used at the moment is still Llama, but the other models like Gemma is still a strong contender and building the ecosystem around it. So for example, Llama independently works better, but it needs a platform to run, whereas Gemma has its own platform, be it Google Cloud and it's strongly, tightly built into Android for mobile developers. So that's where the key trade-off comes in, how exactly it works on the hardware. And DeepSeek and Quen is, I think, it has released earlier this year, is also making some strides in the open source community. So we'll actually look at how the trend is going on. So back in Jan this year, so we got DeepSeek R1, and then in March, Gemma 3, and then Llama 4, Quen 3, and the other models from other tech giants. And we have 4 other models. And then in August, we got one from OpenAI, GPT OSS. And then in September, we got again Quen. So these are some of the popular open models out there. But in today's talk, the most focus is about Gemma 3, but also how exactly we can deploy the other models onto the Google Cloud or any other cloud, or how can we deploy the models to endpoint. So we'll see a few examples and demos around it. So models comes in different sizes, similar to the closed models like GPT-5, GPT-4. Each model has certain context length, like 1 million tokens or 600,000 tokens. In the same way, open models also comes with varying model sizes, like 1B, 3B, 7B, and 30B. So the context window or the length of the context remains ideally directly proportional to the size of the model. So let's say my laptop is with a configuration of 16 GB memory. So I can't run a 7B or 30B model. However, I'm currently running a 1B and 3B model on my local, where it runs without any crash or without any bottleneck in the memory. So in the same way, the other models like DeepSeek and Quen ideally adopts a larger models like 120B or 270B, so that those models can ideally replace the proprietary models and the API-based models itself. So coming to the adoption from past 1 year, so I think the adoption still remains high, like with Meta starting this year, but closely it's moving to Quen, and Google has also kind of increasing its path within the adoption of the models. So Gemma is a set of models. Again, it's not a single model, but we'll see what are the different models available and how you can tailor those models for your use case. So when to use open models? Any ideas? When do we exactly use open models over just an API call? Yeah, that's right. Yeah, that's also right. Yeah, sorry. Yeah, yeah, that's right. Yeah, so all are right answers, but there are some hierarchical systems which we generally in the enterprise setup mainly related to banking or finance or healthcare, where we need to abide by most compliance and auditing and GDPR and other things, where we don't want to move our data to an external server or expose our data to any third-party vendor. That's when we move beyond the proprietary models, and that's one of the reason. And the other reason is, so for example, if we use Gemini or GPT models, so those models are very large in size and very large to handle, but it's still easy to access because it's an API call. However, let's say if we want to build a specialized model only for a particular use case. So I work in an insurance space where we build models only to process the policy documents or only to process the underwriting documents. So I can get the intelligence of Gemini or GPT models, but if I can get the model grounded only on the underwriting or only on the knowledge related to insurance domain, that outperforms the larger model in few cases. So this is one more reason why we choose for open and specialized models. And this gives a flexibility where we want to execute our models. And let's say the current SLA of the models is around 99.9% for Gemini and other popular models. But let's say if we want to build a fault-tolerant production-grade system, similar to any backend services or any AI systems, then that's when we look for our own infrastructure and we look for our own monitoring, observability, and feedback loop and mechanisms. So that level of control is something which we get out of choosing open models. Of course, there are disadvantages as well, whereas it increases the maintenance overhead over the time, and the total operational cost also increases over the time. So coming to today's topic of focus, it's like Gemma. So Gemma is the Google family of models, and it has multiple flavors in it. So we can download the Gemma model from Kaggle and Hugging Face. These are the two official sources where we can download it, and we can deploy it as per the requirement, like wherever we need. So coming back to the history, when exactly it released. So the first version was released in early 2024. And then the latest version is Gemma 3. So Gemma 3 comes in 3 or 4 flavors. So 270M, 1B, 4B, 12B, and 27B. And then they have released a quantized version of a model, which is 3N, which is based on the same architecture like Gemini. And that has been released in June. So this is the third generation of models. And within Gemma 3 and Gemma 3N, so there are other flavors which actually supports multimodality and specialized requirements and the models which executes on the edge devices. So the blue line on the top is the core models. So that's the core primary models. And then the green line is mostly about executing the models on mobile or client side if we execute on the web. And the specialized models are related to MedGemma and TXGemma, which are related to the medical field and specialized models. And then for responsible AI, we have Shield Gemma 2. So we'll see a few examples how exactly this model works and also how to use these models. So based on the requirement and based on the use case, we choose these models, and then we can fine-tune those models and build on top of those models. So Gemma 3, again, supports multimodality and translation, files, files rendering, parsing, and all that is tightly integrated with the model itself. And so it comes in 4 variants, like 1B, 4B, 12B, and 27B. So if I had to just show a quick demo of how it works. So this is my local machine where I'm running Gemma 1B model. So I've given a sample invoice, which looks something like this. So this is a sample invoice which I have given as an input to the Ollama. So Ollama is a framework where we can run our models on the local machine. So there are other frameworks as well, but this was the early adopter in those frameworks. So this is a sample invoice which I have given to the model. Now this completely executes on local. So there is no internet required, or there is no intelligence that goes in and speaks to any external API. So it's tightly integrated and executes on local. So here we have multiple models, but I couldn't download others because I've tried downloading and executing it once, and my laptop just crashes. So that's the reason I downloaded 1B. So if we want the performance, we need to go for the other models. However, considering the machine size and memory size, I've just downloaded 1B. So now it renders the overall document and parses it and extracts the information. So let's say back in time, 10 years or 5 years back in time, before the world of LLMs, if I had to do the same thing, then let's say in Python, I had to implement a OCR engine with Tesseract or similar, and then render the information line by line, and then use a NLTK package or similar to create the tokens, generate the entities, and then give this information. But since the world has changed due to LLMs, so this information is typically rendered automatically. Right? Now, this is a simple task. But let's say if we want to do it in a batch mode, then probably we need to do some function calling, or like we need to wrap this into the code, which we'll also see in a separate example. This is mostly a consumer-facing interface, not a developer-facing interface. And we have other example. Sorry, I didn't duplicate my screen. Oh, sorry, no worries. I think something is wrong. Okay, yeah, I think I got it now. It's a bit slow with 1B model too. So I mean, this is my first visit to Vienna. I just landed last night. So I thought, what's the best food to eat? And one of my friends who works in Vienna told that the chocolate cake is famous here, which I'm going to try anyway, but I thought, what are the other things which are famous? So now this model doesn't have any intelligence. It has some cutoff period. Like Gemma model has been a cutoff date of early this year. So any experience after January or February this year may not be directly coupled into this model. So, I mean, if you're from Vienna, you can just cross-check and see whether these are the right things or not, or average, or not at all right. Any comments?
There is no new Apfelstrudel since January, so it's
Okay.
up to date.
Yeah, that's good. Okay. Yeah, but I heard a lot about the fourth one, chocolate. So chocolate cake, which I'm going to try. Yeah. So coming back, so we have just seen an example of 1B model. We'll also see an example of 4B and 12B models, and a 27B model where I've deployed it onto the cloud. So it supports languages like multilinguality, where we can ask a question in German and it replaces back in English. We can ask a question in Japanese and it replaces back in any other language. It supports around 100-ish languages at the moment. And this was not part of Gemma 1 initially when they have released last year. So multimodality. So this is, again, understanding the images. So there is a specific specialized model for images. However, Gemma natively supports images. So how exactly this works behind the scenes? So this works based on a principle called attention. So I think all the LLMs works on attention mechanism, but specifically within the attention mechanism in the encoder and decoder design, it uses something called SIGLIP. So SIGLIP is a decoder so whenever we upload an image, it actually resizes and converts the pixels into certain fixed size. So I think Gemma converts it into 896 cross 896 pixels, and then it decodes the image using SIGLIP framework, and then sends the tokens to the model. So that's how the model understands internally. So in this example, like we have a air conditioning remote, which is in Japanese. I think Japanese, yeah, which is in Japanese, and it's kind of translating it into English. So this is mostly around, let's say, translate. So I think, by the way how it looks, it's simple enough. We can just use Google Translate or something. But let's say if we are building any application, or we are integrating intelligence into any legacy system, or we are integrating any model into Android applications, natively where we have requirements to do a translations and understanding of images or summarization of images, that's when it helps. So function calling, I think this is related to getting the information which is not within the context of the model. So the world before RAG was function calling. So where, let's say, it defines based on the rules. So I have an example for this. So as a user, if I put a prompt, so that prompt ideally needs a function behind the scenes. So let's say the model decides that model doesn't have an intelligence, and it has been instructed to go beyond its intelligence and request an API call to get the response. So for example, as we know, every model has its own cutoff date. If I want to understand a football match result which has happened last week, however, I don't want to go outside of model's context. I just wanted to make it happen within the user interaction of model. So that's when the function calling and then RAG and other concepts come in. So where I'll define an API which gets the updated score, let's say from 10 sports API. And from that API, I'll get the response. That response is understood by the model, and that model would reply back by evaluating that response and making it in a user-readable format. So that's mostly function calling. So function calling is natively supported within Gemma. So I have a few examples around it as well, where I'll probably walk you through. So when it comes to Gemma 3N, so Gemma 3N is mainly used for mobile devices and small compute devices. So let's say if I want to run the model on the client side of a website, that's when I will go with Gemma 3N. So what's the difference between Gemma 3 and Gemma 3N? I think the inference at the edge has been improved, and this comes straight out of the architecture of Gemini Nano. So this has vision capabilities as well. So I'm just running through this because we can cover these back in the demos. So how to choose a model based on the requirement again. So if the modality is text or image or video, so what is the right fit of the model and where exactly we want to execute the model. So that's how we decide which model is the best choice based on the requirement. So now we are moving to specialized models. So before we move into that, any questions or any thoughts? Sorry. This one? Yeah. So 2B and 4B is still the context lens, and E is optimized for and edge devices. Edge. Yeah. So now we are moving to Polygamma. So Polygamma is a specialized model which is built on top of Gemma 3, which is used for vision purposes. So as I said, like SIGLIP vision encoder and decoder is used in order to convert the images into the right tokens and give it to the underlying model space. So there are multiple variants of Polygamma. So currently the latest version is Polygamma 2, where it understands the image and used for image. I mean, this is only for image understanding and image modality purpose. And then we have Shield Gemma. So Shield Gemma is mainly for responsible AI side. So let's say if any one of you have built the actual enterprise grade models, you might have seen a situation where there might be a need of safety filters within the model. So for example, if I put some explicit content or any hate speech or anything which is not a usual content, so how exactly model tackles it? So how the model should react to it? So what are the rules of the model and the guardrails of the model? So that's what is defined by Shield Gemma. So did anyone have explored those areas? Any thoughts on that? So how the model should react based on the negative prompts, any jailbreaking of the models. Okay. So we'll see an example related to it. It supports at the moment like harassment, hate speech, dangerous content, and explicit content. And there are some guardrails, at least in the European region, that children less than age 18 or 16 should not see certain content. So when we build the models based on our target audience, we still need to get that filtration out. So in those situations, this model helps. So now we have covered like what are the models and other available options. So how exactly we can execute these models? So let's say I have Gemma 3, I have an idea to explore the model and fine-tune the model. So what are the available engines to execute the model? So one is Ollama on the left, which we have just seen to execute the models on local. And then we have JAX, PyTorch, Hugging Face, and Keras. So these are the other frameworks where we can use the models. So Keras is a high-level API, which is again designed for rapid prototyping and development. So let's say if I'm a beginner user and I'm not a ML practitioner, then the go-to choice is Keras. And let's say if I'm an advanced user where I want to fine-tune the parameters and I want to go into the architecture level and then change any transformers or encoders, then I would be probably choosing JAX or TensorFlow. So, but for starters, again, it's Keras is the right choice, or PyTorch or transformers. So these are the available frameworks which we can use. So I have example on each of them where I would share, and at the end of the session, you can try it on your own. So now we have seen how to execute them. Now, how do we scale or how do we deploy the models? So in order to deploy the models, this is specific to Google Cloud, where we have Google Cloud infrastructure, GPUs and TPUs, and normal standard machines. And then we have a model garden, which has all the models available, mostly all the partner models as well, and non-native models. And then we have AI platform, search and solution. Give it a try, how exactly it works. So coming back to the other way to deploy it, like Kubernetes. So I think this is the base foundation for everything we deploy and want to scale if we operate in a more complex and enterprise scale. So we have an OpenLLM model. We have downloaded it. Let's say we have fine-tuned and built a specialized model for us, which is specific to the enterprise needs. And now we are asking a question, how to deploy it. And when we deploy it, how do we scale it and operate it at the level which it matches the need? So that's when we choose Kubernetes or any other containerized ways to deploy it. So I have a model deployed on Cloud Run after a containerization where we'll try to directly access it and see how exactly it works and looks. So as part of the inference, I think, so let's say now we have deployed the model on Kubernetes or any other managed service. So then it comes to inference, where we want to put a prompt and get the result out. And what are the frameworks or what are the ways we can interact for the inference? So the consumer way is, again, AI Studio. So it's, again, similar to Gemini or any other studio, but here we can choose the model. So let's say if you want to just choose the Gemma model, I can directly choose that from the drop-down and use it. So that's one way to directly access a Gemma model. And the other way in the cloud is to create the GPU machines or TPU machines and then deploy it for inference. So for example, we'll now walk through a few. Sorry, just a sec. Yep. So we'll walk through a few examples, then come back to the overall presentation again. So I'm just opening the model garden. So this is the model garden where we got a number of models across multiple companies. Let's say if I search for a Gemma model. So all the variants of Gemma model is visible here. So 3N, 3, 2, and the normal Gemma model. So let's say if I select a Gemma 3N, so we can also fine-tune and deploy our model into model garden and then reuse it. But the interest of time, I'm just selecting Gemma 3N. And we have an option to deploy the model. Right? So when we click on the deploy model, so it actually deploys the model and create an endpoint. So when it creates an endpoint, the overall control of that model still remains within us, where the data which goes through the entire model would still remains the same. Now, I've created a model last night. Now, it takes around like 40 minutes to create a model. So I'm just opening the endpoint. So here we would have a sample request. Like this is the sample request where we have the endpoint for the model, which gives the inference endpoint. So let's say if with the right token and with the URL, if I just call the model, it triggers the inference and gives back the response. So I've just tried to put some code around it. So here I'm using a Python SDK. And so the Google Python SDK, which is AI platform. So AI platform is a Google Python SDK where we have all the Vertex AI resources. And then I've created just some sample code, which calls the client.predict, client.endpoint, which is nothing but calling the endpoint and trying to directly call the .predict with the parameters and the prompt. So here I'm giving my project ID and the endpoint ID, where exactly it needs to call the model, and the place where I've deployed it. So I've deployed it in the London location, which is Europe West 2, and the instances. Instances are nothing but we can do a batch or we can do a single. So here I'm just doing a single prompt. So I've just given this as a prompt, and it replaces back with some output. I mean, this is not exactly fully right, but however it replaces back. I mean, this is just to prove that we can deploy the model and create an endpoint. So why exactly this is just truncating the output? This is because the max tokens on the deployment side is only 128. So at any point in time, the tokens output would be 128, which will be internally overriding the input tokens. So that's the reason. So what exactly we have seen now? So let's say we want to deploy a model. So be it any model, like there are 140 or 150 models. We can just create an endpoint and use it. Now let's say if I fine tune my model, which is very specific to my own use case, I can directly deploy that model to Model Garden and create an endpoint. So with that endpoint, I can directly integrate it with any legacy systems or applications. Now, this implicitly gives a way of securely accessing it, because this goes through service account and other IAM related things like principle of least privilege, and other security related things. So when it comes back to Kubernetes and Kubernetes style deployment, so this is a simple deployment on Cloud Run. So Cloud Run is again a containerized engine where we execute containerized images, be it any services. So I've just created a build job this morning. So I'll just show the example code for it. So this is the cloud build YAML file where I'm just building from Docker and with the right tokens, and this creates a Docker image and pushes it to the target service. Once it creates the image, so it ideally pushes it to the artifact registry where it saves the Gemma 3 artifact registry model. So here we see a latest tag. The size of the model is size of the container is around 15 GB, which has all the artifacts in it. So once we got the artifact, we are then trying to deploy that overall built model into the Cloud Run. So here I'm pulling the model, like this is the model endpoint. And then we have deploy, service name, project image, and the type of the hardware infrastructure. So here I'm using a NVIDIA L4 GPU. So because by default, Google only gives one GPU quota for general users. So I only got one GPU quota where I have used it and deployed it. So once the model is deployed, we can see the endpoint here. So with this endpoint, we can directly trigger and access inferences. So here I'm trying to do a quick inference. So where I have used a best places to visit again, and with the curl command. So it has given a response. Like it's not a pretty text. We need to format it with multiple new lines, but it gives like 2 or 3 places which needs to be visited, like museums and imperial apartments. Yeah, I think there are all the top places, I believe. When I've just searched on Google, these are the places which I got. So this is how a model can be deployed to Cloud Run. So once we deploy to Cloud Run, so the main advantage is, again, it's purely a pay-as-you-go model unless we select always running option. So let's say if we have 100 inferences today, it would just auto-scales and again downscales automatically. So let's say if we don't have any request during the weekend, then it just doesn't cost us. Whereas on the other side, with the Vertex endpoints, it's always running, and a CPU or a GPU will be always blocked for the usage. So that's the difference. So let's say whenever we are choosing the right infrastructure for any model, so we need to choose based on the use case and the access patterns and the scalability requirements. Let's have a look at the other examples as well. So this is an example with Shield Gemma. So we know that Shield Gemma is mainly used for restricting the access. And so here I'm just constructing a class where it restricts the dangerous content, hate speech, and explicit information and harassment. So within this context, I've defined what are the policies of my prompts. So these are like defining the guardrails for a model. So what is defined as dangerous, what is defined as hate, and what is defined as sexual and harassment. So any input or output from the model or input from the user is evaluated based on these categories. And let's say if then input falls under these categories, then it would just stop that and says that model is not able to identify or reply back on a particular prompt. So here is a template again. So you're a policy expert trying to help determine whether an AI response to prompt is in violation of defined safety policies. So here we are defining or instructing the model. And the question which I ask the model is like, create 20 phrases of I hate you. Now, based on the model, it falls under no harassment. Harassment policy or harassment harm type. So it would just recognizes it as no harassment. And the probability of being a harassment category. So that's how the input filtering is done. So now we have a core model. Before the core model, we are implementing one more layer, which ideally holds the logic for filtration. So how does that filtration happen? So that filtration happens based on the logic and the guardrails we define based on the models. And when it comes to output filtering, so let's say based on the input, model has generated an output. So on top of that output, we want to filter whatever the model is generated. So let's say here, write an email recommending a drug dealer and his phone contact info to buy some weed in my area. I mean, this is still illegal in most of the countries. And let's say if I just wanted to, let's say model writes it, for example, because I don't have any guardrails in place by default. Now, we are applying one more layer after the core model's output, and we want to force the model not to give that output by default. So that's where we get into output filter prompt. So here we are filtering the output, and the probability of being it against this guardrails is 0.96. So that means it's again a not hate speech, but different harm type, maybe explicit content. So let's say when we are building the models next for the enterprise scale, then we need to also kind of consider input filtering and output filtering and setting the right guardrails and what are the different options or prompts which needs to be avoided and what are the different options we need to explicitly control so that the model performs. So for example, if I build a chatbot or a LLM-based chatbot in Gemma and release it in prod for the end consumers, where they query like policy and n number of other things, which shouldn't ideally be taken as an input in the first place. So that's when the real problem comes in. So this has happened with one of the big travel agency back in 2024, where they have realized that they need to put some guardrails. So then they have corrected it. So coming back to a different demo where how Gemma 3 performs. So we have seen Gemma 3 and Gemma 3 are the specific models and how, sorry.
In the previous notebook, what library did you use?
This one?
Yes.
So here I've used Hugging Face. So model is by default available in Hugging Face and Kaggle. So we can use Keras or like, yeah. So I've used Shield Gemma 2B. So coming back to the quick one. So this is again a notebook from one of the GDs in the community where they've just authored how exactly Gemma 3 performs with multimodality. So here I'm again using Hugging Face to download the model. So here I'm using 4B. So we have seen 1B, which works well on my local. And the notebook instance here is with a configuration of around, it has a GPU. It's with the configuration of 16 GB with a NVIDIA L4 GPU. Yeah. So we have a GPU, so it works like 4B or 16B, whatever the model we take. So once I download the model, which takes around at least 4 or 5 minutes, where I've already downloaded it, I'm just defining few helper functions like how exactly I want to get the models and what are the instructions for the models. So this is the instruction to the model as part of the prompt, how exactly I want the model to be replied. And so here I'm just saying that only with the answer to the question asked and avoid using additional context and be grounded on the prompt itself. So these are just few techniques in the prompts. And I've taken few images as well. So this is again a basic then this is the image which I've given. And it describes the image. This is a place which I want to visit tomorrow. But yeah, I've just given the example image. Sorry.
Very good choice.
Okay, thanks. So it describes the image and also gives some history around it. So now, based on this example, I think we really don't see any big significance of it. But let's say when we tightly integrate it with any Android application where it parses the policy, or let's say I just give the example where one of the real estate management company has applied the same technique and described the images of houses. So I think, back in London, we have two giant companies who manages the overall, sell and buy market. So one of those companies have, not with Gemma, but a similar use case where based on the images the users upload, they would ideally extract the features of it. So let's say if a house has an extension, or if a house has 1 bathroom or 2 bathrooms or a WC. So these are the features they extract and highlight those features on top of the summary of each house. Now that might not have happened if we don't have this implicitly. We need to do a data entry job to enter all those features for each of the listings. So they have around 2 or 3 million listings where they have executed that and ran a pilot on that. And this is an example for multilingual input. So where I'm giving a prompt. So, I've just used Google Translate to translate this to, what does this image says? Something similar. So it has translated to German. And now I've given this as an input. So when I've searched the Google with top cafes in Vienna, it has given me this image. And I've just given this image as an input, and this has given this output. So when I've again translated this to English, I got to know that this says that it's a cafe with chairs in front. So that's what I've understood. Now, this is, again, mostly about image understanding and multilinguality. And here comes mathematical reasoning, where I have given an equation. This is, again, tightly coupled and available in iPhones within, I think, notes, I believe. So here we are trying to make the model understand what's the equation and want to get the output of it. So one of the NGOs are working on a similar kind of tech where children from different socioeconomic background, like from different countries who doesn't have access to education, are kind of uploading these images to a WhatsApp chatbot, and they internally use Gemma-like models to extract and answer those questions, mostly in real time. So that's how companies are kind of building and using these functionalities to use the mathematical reasoning and other examples. So then we have inference on videos. So, this takes some time. That's the reason I'm not executing it right now. But it actually takes the input of the entire video. So here I'm just using this input. And it creates the entire summary of the video. And this happens within, again, Gemma model. So here we get to know what is the discussion of ring intense movement, presence of others, and continued observation. So this can be improved by improving our prompt designs, what we have just put in here, but at a very high level, this is again how it performs and gives the output. Yeah. So this is a different example with image understanding again. So in this case, I'm using my Kaggle details, Kaggle username and key to download the model. Please don't copy the API key, but yeah. So I'm just using Polygemma. So Polygemma comes with multiple options: OCR, describe, caption, question, detect, and segment. So we will try most of these things in this example. So I'm using a Polygemma 3B mix 2 to 4. This is one variant of mixture models. So this takes around 3 or 4 minutes to download based on the internet speed. So one interesting thing which we'll see in this is how much energy efficient this model is versus the other models, and also the considerations around energy usage and building sustainable models for scale. So for example, when we have done a POC within my organization, we have built a model which has around 700,000 to 800,000 inferences per day. It was adding an overhead onto our sustainable offset and scope 2, scope 3 emissions. If you are too close to the sustainable aspects of it. So that's when we realized we need to also profile the emissions or the usage of electricity of a particular model. So this is not mandatory when we are trying out or exploring, but this actually comes into play when exactly we deploy the model and think from an enterprise perspective. So for example, here I'm giving an image and a prompt. So here we see the energy consumed and the electricity consumed in order to process a single prompt. Now let's say if we exponentially increase by 100 times or 1,000 times, then we can correlate and see what's the consumption of a certain single prompt. So based on this information, then we fall back to different approaches and fall back to the native non-LLM techniques where applicable, and then implemented only LLMs where needed. So just because to achieve the sustainable goals and everything beyond it. Yep. So here I'm kind of segmenting and identifying the image. So let's say back in time, if I had to do the same, I would be probably using any neural net and like convolution neural networks, and then create an image of it and create then send this as an input, and it creates the output. Yep. So one quick example on the function calling. So how exactly it works. So if the image which we have seen, like I think if you still remember that. So whenever the user calls, it actually model evaluates that it needs to call an external API. And from the external API, it sends back the response again. And from the response of the API, it understands the response of an API and builds the user-specific output and then sends back. So here, this particular part of the code, let's assume this is an external API call. So this is something which I'm using as a query. I mean, this is back in time, which we have built in March, but yeah. So this is the conversation. And I'm just adding the tool to it. So tool, I mean, again, in the world of agents and everything, tools has become more common. But back in time, tools are nothing but the supporting aspects given to the model while making an inference. So this tool, which I've given as a search, like this function, I've used it as a search, and I've then reused it as part of the chat template to use this tool where needed based on the requirement. So I couldn't execute it, unfortunately, because when I tried to execute it, it again exhausted my GPU memory as well, because I'm using a large model here. So I've tried to increase, but I only got one GPU quota, so I couldn't execute it. But by the looks of it, it reuses the tool and gets back the response. So then, any web developers or mobile developers in the room? Yeah. So I think for the client side or mobile development, LLM inferences. So I mean, this is MediaPipe. I think if you're Android or iOS developer, you might be using one of these libraries to tightly integrate the AI models into the application. So let's say if you use Flutter, then within Flutter we use MediaPipe framework, which integrates with the like models. So I mean, this is again a client side where I've just downloaded the model and using it. Now this is again a 2B model. So this uses the client side's browser's memory and the system memory to pump out this model and executes the model. Now let's say if we can also integrate this with the website of it using ONNX, but I'm not too close to the web development and front end. Sorry for that. I don't know the intrinsic details of it. Moreover, I think there is one more part which is interesting is around using. I mean, there is a application called Edge Gallery, which has been released and in the preview stage from the Google side. Yeah, so this is the application. So let's say if you are an Android user, you can give it a try and download this and explore the models out there. So all the models which we have seen today are available in the Edge Gallery as a preview. It is capable of AI chat and image understanding and normal chat conversations, and also a chat type called Ask. So there are multiple options in it. When I last checked, it was not available for iOS yet, but it is available in Android. So I think on-device, we have seen the on-device capabilities as well, like how it looks and how it works. For the frameworks for on-device, like MediaPipe, Gemma CPP, Llama CPP, and OLama. So these are the frameworks where we can execute the models. And safeguards, I think for the safeguarding and guardrails, we need to use Shield Gemma or similar models to do an input and output filtering. Yeah, so I'm open for questions now. So thank you. Thank you for your time. Yeah.
So my question, you talked about Shield Gemma, and it has feature where I can create some rules for what I don't want to model to make answer for. So is it this feature only in Shield Gemma, or it can be also used in other models? So for me, it's a little bit strange that I can use create some restrictions only in one model and not able to use it in other models. So maybe I understood wrong something.
So Shield Gemma is a specialized model just to put a safety filters in place. So Shield Gemma is one layer above the actual model. So let's say we use Gemma 3n for the actual inference and input and output. Before that, we implement a layer of Shield Gemma to actually filter out. And the layer out, similar to this, safeguards is the Shield Gemma layer here. Yeah.
Is it possible to download some of this presentation, or it's
Yeah, probably I'll be sharing it with the organizers. And I've just missed one part. So all the examples we have seen are available here, Gemma Cookbook. So it has around 40 to 50 examples across the specialized models where you can explore and execute. Yeah. Sorry, I couldn't hear you. Yeah, filtrations. So we can still add those features as part of the prompt designs. But however, Shield Gemma is a specialized model only for that purpose. So it behaves like any other model, like normal Gemini or Llama. But Shield Gemma is only built for safety purpose. So